We are continuing on today with rate of change and slope day 2. This is just going to be some more practice, extra reminders. I'm going to go through a couple of examples here. Just a few refreshers. We want to remember that rate of change is the change in the y values over the change in the x values. So in terms of the slope formula, our formula looks like y2 minus y1 over x2 minus x1. And that is, of course, given that we have 2 points, x1, y1, and x2 and y2. Sorry, y'all can hear my dogs barking in the background. They're playing. And so we've got a few examples. We're going to just start off with example 1. I'm in the wrong place. Here we have a table that shows the distance a car has driven on 1 tank of gas. It says find the rate of change for the following gallon ranges. So we're going to look first. We have a table here, and it says specifically for us to use the gas as the independent variable. So that means the gas used is going to be our x value. So gas used, I'm going to put an x in front of it, and then that leaves our miles to be our y. So this might look a little different than some of the tables we've looked at. So that's why I wrote the x and y there, because that'll help me remember. And it gives us 2 different ranges to find. So we have the rate of change of 0 to 2 gallons, 0 to 2 gallons. So I'm going to start off and highlight this, 0 to 2 gallons. And so we're going to look at, that's really big. Let's make it smaller. We're going to look at this set of information here. We're going to have 2 ordered pairs from that piece, and that's going to be 0, 0, and 260. And we will do slope formula with this. Just a reminder, if you need to put x1, y1, and x2, y2 underneath, feel free to do so. So with those points, I plug that into my slope formula. Again, that slope formula is in the top left corner of your paper. And if you are comfortable with doing this on a calculator, you can do that to check your answer. So 60 minus 0 over 2 minus 0. It gives me 60 over 2. 60 divided by 2 gives us 30. And if you think about our units of measurement, we have miles driven and gallons of gas used. This is saying that the rate of change from 0 to 2 gallons was 30 miles per gallon. Okay. Then we have a second set here. I'm just going to put a little divider line to help me remember. And that second divider line, let's give myself that color, is from 6 to 9 gallons. And so we are working in this range here, those 2 sets of numbers. So my ordered pairs are going to say 6, 170, and 9, 230. So again, those are going to be our x and y values. So we have x1, y1, x2, y2. We plug these into that slope formula. 230 minus 170 over 90 minus 6, not 90 minus 3. 230 minus 170 is 60, and 9 minus 6 is 3. So that gives me 20 miles per gallon. So at certain points in your drive, depending on how you've been driving, the rate of change for miles per gallon can change. And so that's in those ranges of 6 to 9 gallons and 0 to 2 gallons, how those rate of changes were impacted. Okay, here we have 2 examples of ordered pairs, and we're going to find the slope. Again, you can put x1, y1, x2, y2 to help yourself. got two problems here, so I'm going to give myself a little divider line. And so this is going to be 6 minus and negative 3 over 9 minus 0. 6 minus and negative 3 turns into 6 plus 3. And 9 minus 0 on the bottom. 6 plus 3 is 9. 9 minus 0 is 9. This just turns into 1. So it has a slope of 1. Our next example provides us with negative 9, negative 1 as our x1, y1, and negative 1, negative 5 as our x2, y2. So again, we're going to plug this into our formula. Negative 5 minus a negative 1 over negative 1 minus a negative 9. When we take those subtraction with a negative, that's going to turn into negative 5 plus 1 and negative 1 plus 9. negative 5 plus 1 is negative 4, and negative 1 plus 9 gives us 8. When we reduce this, this reduces to 1/2, negative 1/2. So our slope is negative 1/2. Example 4 here. Our next example is of a graph. When we are trying to find the slope of a graph, you can use the slope formula or you can count rise over run. Either way, you always want to look for two really pretty points that meet at an intersection of the cross-section of the graph. So looking at my line that is graphed, I see a good point here. And tracking down, I see another good point. The first point, the farthest point to the left, is at negative 3, 2. And the second point is at negative 1, negative 4. So you can do slope formula using those 2 points. So again, negative 3, 2, and negative 1, negative 4, or you can count rise over run. So I'm going to do this using rise over run because we've already practiced using slope formula. So going through this for rise over run, I'm going to start at my lefternmost point, which is that negative 3, 2. And I have to decide to rise up or fall down. When we are trying to travel to the right, I'm trying to get to that negative 1, negative 4. I'm going to have to go down 1, 2, 3, 4, 5, 6. I'm going to go down 6. So instead of rising up, I am falling down 6. And then I am going to slide to the right 1, 2 steps total. So, sliding to the right 2. Anytime that we fall down or our negative or our slope goes to the left, goes to the bottom right corner instead of the upper right corner, we're going to do a negative slope. So that's a negative 6 over 2. And that is going to reduce to a slope of negative 3. So our slope is negative 3 here. You can always double check yourself with the slope formula as well. And we'll be back with some more examples in a moment.